This is one of my original turntables that I bought when I was probably 16 or 17. I'm going to say 1980, maybe 81. I think in 1980. I used to use it for DJ work, mixing custom tapes with two turntables. This was one of them. This was my good one. This was my Sony PS-T22 direct drive, servo controlled. And I also had a cheap Sanyo, which is long gone. It was a belt drive. It was a plastic piece of crap. Anyway, this one no longer works. This is one of my original turntables that I had when I was young. I think I probably bought this one early 1980s, I'm going to say. I had two turntables. I had this one and I had a Sanyo belt drive. And the Sanyo belt drive actually had a really nice cartridge. It had an Empire 4000 cartridge on it. Unfortunately, I gave that one to my brother-in-law when I got my Technics SLM1. I loaned it to him. I never got it back. Just like I never got back my JMJ vinyls. I had Oxygen, Equinox, and Magnetic Field on vinyl and never got those back. And when he moved to Australia, he got rid of everything and didn't offer it back to me. Nice, huh? Anyway, this was one of my two turntables. This has been modified. It has a DJ switch on it. What this was for is I used to mix music. I had two turntables into a mixer, and I used to spin records and make mixed tapes with cross dissolve between the two of them. So I would cue the record up, I'd have the record playing, shut it off, back it up one turn or whatever. The Technics, it only takes a quarter turn to get up to speed. This one took a full turn, but then I could turn it on and the motor would start up, it would get up to speed, and my music would start to play. This one hasn't been used in probably 30 or 35 years. I took it out of service. Well, I used this when I lived at home at my parents' place, and I moved out of that place in the 80s, late 80s. I was out of there, so this was all taken down, and I don't think I ever had it set up at this place, because by the time I moved into this place I am now, the house, I bought it in '93, I was dealing completely with, oh, that needle's kind of bent. I was dealing completely with CDs. So right now, I can tell right now that the stylus on this thing is shot. If we look at the needle is bent on this one, so right off the bat, it's going to need a new needle unless I can kind of straighten that cantilever a bit, which I just did. But anyway, that's the least of my concerns. Another thing with the Sony is it used a smaller head shell, not the standard size head shell connector that everybody else used. Anyway, let's see whether this thing even works, because at this point in the game, I don't even know if this turntable turns on. I haven't powered it up yet. I've plugged it in. Let's see if it even turns. That was run, that was stop. So the motor doesn't turn at all. Let's take a look under here. Just take a look at the motor on this one. Motor is actually under the turntable, but I wanted to show this part off. It uses a magnetic pickup head. And on the inside of the actual platter, it looks like magnetic tape. And that's basically what it is. They've sprayed the inner circumference with a magnetic compound, which has got a signal recorded in it, and that is picked up by this head that's on the base of the unit here. This is a frequency generator, which is used to operate the motor, control the speed. But it did not appear to try to spin up at all when I'm going to take the cartridge off here is to not damage this anymore. So when I lift the arm, you'll see that the motor is rotating when there's no platter installed. The switch doesn't seem to make any difference. But when the clatter is on, oh, now it's starting to turn a little bit. It's nowhere near the right speed. Maybe we have capacitors that are going bad on this thing. Now when this is in the off position, this should not rotate, and it is. Let's get a look underneath the unit itself. So let me just get the bottom cover off it. We'll take a look at the circuitry. Well, here's the servo board on this one. It's got AC power over here, that's why I've unplugged it. And here's the motor. You see the motor wires going over to the motor. I'm just looking to see if there's any damage. I don't know if any insects or critters got into this thing while it was in storage. It was stored in a garage, so first things first, we're going to do an inspection and just see if there's any corrosion on the top side of the board, because it was sitting in a box, but you never know if critters crawled in here. Could find some dead bugs shorting out the top side of the board here. So first things first, let's remove the motor. This is the pickup coil here that goes to the board there. Okay, this should lift the motor out and the servo board, which it does. A couple filter caps on here, which we may have some bad caps. That might be why it's not operating. As you can see, here's our rotor and our 4 coils for the direct drive motor. Got 4 drive transistors here and our servo control. These are going to be gain controls. Looking at all the oxidation on here, I bet these need to be cleaned. So let's just, first things first, let's just give these a shot of cleaner. We'll clean these controls up and see whether that makes any changes to the way that the motor tries to operate. These are actually gain controls. They're probably gain for the 4 channels for the drive. The speed adjustments are going to be down here. But all 4 of these resistors look like they've been exposed to moisture and so forth over the years, so we'll give them all a shot of cleaner and just rotate them ever so slightly back and forth a few times. Try to set them back roughly where they are. I'll power the unit up now and see whether the motor tries to turn any faster than it did before when I lift the arm. Turn on the switch. Switch is over here. Okay, power is on. We're going to check these caps. There's basically 5 electrolytics in here. A couple of them will be in the power supply and a few of them will be in the servo circuit. We're going to check them out and just see what the ESR is on them and change as required. Yeah, I know it's flashing B because the battery is low, but it's zeroed out. So it will work. Don't worry. Okay, we'll just discharge these caps and just measure. 0.13, probably okay. The next one here is 0.12, that's also probably okay. And there's another little one over here. 50 ohms. I would say that this little cap here, C6, is probably no good. We'll check the other 2 that are over here. These are just filters, but we'll take a look at them. 0.06. That one's probably okay. And there's one more, I think. There's one more next to it over here. And this one here is 0.02. So I'm going to start by just changing this one here, C6, which is measuring at 48 ohms. Definitely that one's open. Now, in case you're wondering what this is made out of, this is not plastic. This is like a composite. It feels like aluminum, but it's not. It is a metal type of an alloy, for sure. It's like a composite, but it feels like metal. It almost feels like aluminum. Maybe powdered aluminum that's been formed. That might be what it is. Like a sintered type. It definitely feels rough, right? Like it's not been cast. It's not nice and smooth. But it is definitely a metal of some type. They called it an anti-resonance base on this. Compared to the plastic ones that were around of the day, this one here did not resonate with the music when you had the bass cranked up, whereas some of the plastic ones, well, they had a tendency to really resonate. So this cap is a 1 microfarad at 50 volts, and if we look at the meter, it's measuring, what's it say here? Oh. Well, I guess I have to get a new battery because my ESR meter just decided to go right out completely. Yeah, you see? Now I gotta find a new 9-volt battery. Good luck. We'll just measure the capacitance of this cap. It measured high in circuit, but we'll just check it on the good old fluke. It's measuring 1 microfarad, so maybe it's okay. Maybe the ESR meter was just too low to give me an accurate reading. I have to go and look and see if I've got any 9-volt batteries around here. I did, but I think I've used them all. Okay, I got a new battery. Let's change the battery on the meter. I haven't had to do this very often. It's been a few years since I've changed it. At least a few years. I don't know if you guys have ever seen the inside of this thing or not. I think I've showed it off once. Used before March 2021. Okay, well, I used it before March 2021. This one here that's going in, this is one I've had for a while. I don't know if it's any good or not. It's an old Ever-Ready Energizer. I don't know if it's any good. We'll find out pretty quick. So snap the new battery in place, observing polarity. And as you can see, this is the circuit board. This is home built. This is how it's insulated, a piece of cardboard. Believe it or not, that's the quality of my meter. This was a kit that I built at least 30 years ago. More than that. probably closer to 35. I think I probably built this meter maybe around 1988 to 1990, somewhere there. I don't remember the exact year. I had it at the shop for a long time. I had to beg and plead with the boss to let me build a meter because he didn't want to pay for it. I had to actually pay for it myself because he wouldn't buy it. Okay, let's measure this cap now. This is the 1 microfarad cap. It's measuring okay microfarad wise, and it's measuring 2.5 ohms out of circuit. Now maybe it was measuring such high reading in circuit because the battery was weak on this tester, but 2.5 is more than good on a 1 microfarad 50 volt, which would be between 14 and 16. So this cap, unfortunately, I thought that was going to be the culprit, but it's apparently not. So I can put this one back on the board. That's not why this unit is running slow. I'll mount the motor again and we'll just check it now that I've cleaned up those controls. Maybe that's made a difference. You know, this metal almost feels like that pot metal that Akai used to use on the cams for the reel-to-reel. That's what this stuff reminds me of. Maybe it's the same stuff. Maybe it's just cheap pot metal. Because it just seems like it's really brittle and will break if I tighten these screws up too tight. My platter's mounted. Power it up and see whether it turns. Nope, still not going nowhere. I wonder if this switch is at fault. Well, that's interesting. It keeps turning if I turn it on. It keeps turning. But if I stop it, it won't start up. Okay, now it is. And when I shut this off, it should stop. And it's not. I wonder if it's something to do with this, maybe the switching in here. Because normally it would stop when I turned off that switch, and then when I hit the switch, it would turn back on and start running. I forget exactly how I modded it. I think we just disconnected the signal from the speed switch. Disconnected that. That just shuts off the power. Like it shuts the speed switch off, and that stops the motor. Let's investigate some more. It is turning, but it's just not running right. This is the speed board, or speed control board with the pitch control and stuff on it. Just going to pull this out of here just so I can see what's under here. That's got the pitch control, which I probably should clean, and the speed controls. I'll give that a shot of cleaner while I'm at it. And I'll clean the other two controls as well while I'm in here. Okay, if we look at how this switch is configured, there's a black wire and a red wire that went up to the switch. The red wire is going to the toggle switch to shut it off, and then back to the speed selector switch. And then there's a brown and an orange, which would obviously be for the speed, and they come out and go up to the little speed control board with the pitch control on it, and then the yellow wire returns. So basically what it's doing is the selector switch here is selecting between either the orange wire or the brown wire. If we look on the orange and the brown wires here, you'll see one goes to the 45 RPM selector, and then through a resistor back to RV3. The other one goes through for the 33. So if we look here, point this out here, the 45 goes to the wiper of this variable resistor, this trimmer. The other side of it goes through R2, which then ends up on RV3, terminal on RV3. This center wiper is what goes back on the yellow wire, and the 33 RPM, it goes through a resistor, R3, then into the wiper, and then back up here as well, as you can see. And they've done it this way so that one goes through a resistor first before the wiper, and the other one goes directly into the wiper, and the other side of it comes out and goes through. So these two are basically connected together. This one here going to the pitch control is connected to the wiper of RV2. It's also connected to R2, which is connected to one of the terminals of RV1. But if you look at the other terminal of RV1, it goes to the 45 switch, and the 33 switch goes through a resistor R3. So basically it's, if we look at this, it's the wiper, the trimmer, in series with R2 for 45, and this trimmer in series with R3. Then it goes through RV3 for the pitch control. So any of these could cause the speed problems for it to not work. Also the main speed switch up front here, it could certainly cause it not to work as well. So we'll see if we can get some cleaner into that switch. I'm just trying to see how to take this apart to get into there. I forget how this thing came apart. It's been so long. Obviously I had it apart because I drilled down through the top and mounted that switch, and that switch is over about here. That was a switch that I put on to turn this into a DJ's turntable so that it could operate with the queuing mode. And I have a feeling that if I take out some screws here, that this top piece should pull out on here, I think. So let's just remove these screws and see if this top bezel lifts off. It's a pretty warm one today in the shop, I tell you. Summer's finally here. We've been waiting for this for a while. And finally, we've got some warm weather, or warmer weather. Last year at this time it was like 30 odd degrees. It's only like 20, I guess 25 in the shop today. But it's getting up there, it's starting to warm up. But then hey, we're almost halfway through July. So we've had kind of a lousy spring this year. We're starting to catch up. But that's okay, because the time of year where here when it's generally the hottest is July and August anyway. It's usually our hot months. So this is what I was getting at, okay? So this is the switch that turns it on and off. It's just a single pole switch. Off and on. And then it goes into this other switch here. And if we look at how this one is wired, we will see that there's a black, red, then an orange, and a brown wire. And the black one is probably just a ground. I don't know if it's connected to anything. I don't think it's even connected to the switch. No, it's not. The black wire here is just a ground wire. That's obviously just to ground this bracket, ground the switch, so it doesn't do anything. So it's just the red wire. Red wire, power coming in. It goes through my little toggle switch. Then it goes into this switch. From here, it goes into this speed board and back to the servo. So any problem on any of these switches here could certainly result in it not working. So we'll clean at least this switch. We know how Alps switches are as far as going bad. They're terrible. So we can get some cleaner in here and clean this switch up. All it would take is some resistance, right? And leakage. The fact that my little toggle switch didn't shut the unit off when I shut it off, that should have killed the power completely and shut it right down. Just wanting some cleaner to get down into that switch. I got all the screws in. We'll just turn this over and try running it with the little circuit board out. I just want to see if it'll spin. Once I get the unit spinning, then we'll play around with it and maybe try some other mods to it, like mod it to do 78s. Wouldn't that be something? We could make this thing play 78s. The fact that it spins with the power switch off, that should shut everything down. So we have a problem in the servo control on this one for sure. Let's get back onto that board and check the frequency generator and see if it's actually outputting a signal. Because if the frequency generator is not sending a signal to the control circuit, it's not going to know what to do. First things first, let's make sure that we have our power supply voltages correct. So this unit has a positive 13 and a negative 13 volt supply. They're right down here. They're clearly marked on the board. Minus. Volkswagen should be banned from the street, especially bugs. Minus 13 and positive 13 volts. So here's our negative 13 supply. You guys can see the meter. Turn on the power. Negative 13.5 volts. We go over to the positive 13, and I only have 3 volts. So we clearly have a problem, and that's probably why it's not working. It's because our positive supply is low. So let's find out why. If we look down at the print, we'll see that the voltage comes off the power supply and it charges up C9 and C10. C9 being the positive supply, C10 being the negative supply. And if we look, I've already measured it too. If we look at the voltage here, you'll see that at C10, was it? Did I say C10? C9. C9 here has, can we see the meter? 13 volts. And that's right here. It's good, right on this line here. This line comes up, goes to the motor drive. There's a fusible resistor here. It's a 0.47 ohm. And then this is the capacitor where it's bad. So we can check it at that resistor. It's R16, is it? R16, 0.47. So R16 is right here. So we check the voltage across R16. We'll see a voltage drop. On one side we've got 13 volts. On the other side we've got 3 volts. So that resistor, well, it could be open. Let's measure that resistor. It's supposed to be 0.47 ohms. It's a fusible resistor. So there's a good chance that that resistor is measuring higher than 0.47 ohms. R16. Yeah. 1K. That looks a little bit high. Let's just pop the motor out again. We'll measure that resistor and change it. Remove the spinny part again. You notice I call the platter anything but a platter just to get the turntable purist knows how to joint. I get the guys out there that are never going to watch me again because I call it the wrong thing. So this resistor here is open. Let's just pop it out and replace it with a new one and see whether we get anything different happening. I'm curious as to why the resistor went open. It's probably just from moisture over all the years. Either that or something catastrophic failed on here. Could have been the it could have been overcurrent. It is a fusible resistor, but it's not burnt right up. Usually when these things go, they discolor. But you see 1.2K. And this is supposed to be like 0.47 ohms, I think is what I said it was. Yeah, 0.47. So that's supplying power. See, that supplies power to the servo amp if we look down here. So none of these transistors over here will cause it because it's beyond that. It's providing power to the motor drive amp. Right, that's downstream from the resistor, and this capacitor and the servo amp is all downstream. I guess it's in theory possible that C7 shorted and took it out, but C7 ESR wise measured okay. That resistor just could have failed just due to moisture, I guess. After all, it was sitting in a damp garage. Anyway, let me dig up another one. We'll see if that fixes this. This resistor is a little bit less, or a little bit lower, measuring 1.5 ohms, but my leads are 1.1. If I measure this on the ESR meter, because the ESR meter can test low ohms as well, that's the beauty of it. We zero out the resistance on the leads, and we see that this one's measuring 0.33, which is what this is. The original was a 0.47, but I don't have a 0.47, so a 0.33 is going to have to do. And in this situation, it's not going to make any difference whatsoever. 0.33 will work just fine to replace a 0.47. It's going to get the board. The holes are open on the board here. Okay, pop this in. I know there was I had a viewer a while back that was interested in my 78 records that I showed off before, the old classical records, and he was wanting to buy them from me, but was stumbling on the shipping cost because of the weight, and wanted me to hold on to them for him for a while until he could come up with the funds. If you're watching, I forget who you are, but if you're watching, the records all have been sold. A whole box of 78 records. Went to a new home, went to the same fellow that ended up with the Silvertone stereo. I guess we can check the voltage again, see whether I've got my 13 volt supply, or whether this new resistor is going to burn up immediately. If it burns up immediately, then we've got more problems. If it doesn't burn up, then maybe the motor will run. So this was my My 13-volt supply was here, and 13 volts. There we go, and minus 13 volts. There, see, 13 volts. So, motor should be spinning. Let's see if it is. Guess I should take that tape off there. I put on that to stop the mechanism from cycling. Alright, let's hit the power switch. Ah, it's not turning. Good. Let's see what happens if we flip this switch. Okay, why is it not turning now? Back to square one. Alright, I'm just going to try just cleaning these controls a bit. I'm just going to rock these controls back and forth a bit. These are the gain adjustments for the servos, because there could have been some corrosion on here. Okay, now the motor spins right up with lots of torque, so one of these controls likely had a bit of corrosion on the back side of it. I put some cleaner on before, but now it's had a chance to soak in, and the motor now appears to be spinning. So let's mount it again and try it out. See whether we get some action this time out of this one. Get it spinning at the right speed. And then we can play around with it and see whether I can make it go even faster. And maybe utilize that switch on the front instead of that switch turning on and off the power. Have that switch to set up another speed, let's say, for 78. Never know. It shouldn't be that difficult to add 78 RPM to a turntable like this. I can play my Harry James records on here. My Harry James and Glenn Miller records. Yes, I'm a big fan of Harry James, Glenn Miller, and Benny Goodman. All that stuff, Perry Como, Dean Martin, Frank Sinatra, etc. Yes, I have Harry James and Glenn Miller records on 78. A few. I don't have a lot, but I think I got maybe a dozen. I've been playing them on the little Philips unit that I worked on a couple of weeks ago that I picked up. The one that I got all those 45s with, I've been playing them on that. And they actually sound very good on that unit. It has a proper mono cartridge with a 78 stylus on one side. When you play 78 records with a 78 stylus on a mono cartridge, they actually sound pretty good. And a tube amplifier to boot. Alright. With the power off, this thing shouldn't turn, which it doesn't. When we flip that on, oh look. Look, Ma, it's going. Let's just see if it's going the right speed. Well, I'm sure it's not, so we'll just make sure that we synchronize this thing. I'm going to set the 33 and the 45 speed using the strobe disc here, the built-in strobe, which you guys probably can't see because under these crappy lights it's not going to appear to move because I've got LED lights in here. I got some fluorescence as well, but I have to actually look at it under the neon light. If I shield it, then I can set my speed and get it exact. And it is right on for 45 now. And this one here, 33, is not. Okay. So the switch has probably got a problem. Because I switch it to 33 and it stops. 45 works, 33 doesn't. That would be this switch here, because that's the only difference between one and the other. Or it could be the 33. It could be the 33 pot on the bottom of the this control here. Where is it? We'll just tweak that control. 33 pot right there. Because that was what was wrong with the other one, was the pot was bad. Okay, no 33 speed. We'll take that little board out again. See, on 45 works fine. But the only difference is the switch. So it's either going to be the control is bad, or this switch is bad, and when in the 33 position it's not making a connection. So I gotta pull this apart yet again. I'll maybe pull the bezel off. We'll start at the switch. So I'm curious as to whether the switch is at fault. So if I short the terminals on the switch here, in case the switch is bad, will it start to turn or will it not? So it's not. If I switch it to 45, it does, but let me just make sure I'm getting the pins closed correctly here. Oh, I wasn't. Try this again. I was on the dead side of the switch. Okay, what about that? Will it turn? It's not turning there. Nope, it's not turning. Simulating the switch, in case the switch was bad, I just shortened the wires together. So if I short the down position, you can see it starts to spin. That position is not. So we know that the switch is working, and I could measure the switch too. I could put my meter on there and see that the switch is working. So it's got to be something on the little speed control board. We know that it has to be on the speed control board. It cannot be anything else, because both use the same control wire. It's just switching the voltage between one and the other. As you can see, the switch is actually good, because if I push the switch in, that's now open, and the connection's good over here. Right, so the switch is good. The problem's on this little board over here. Either another resistor has gone open, or a connection, or something, but we got to get at that board once again. Maybe just leave this undone for the time being, because if I want to get in here and add a 78 speed and use that other switch to switch in, and just add another resistor to it, and a variable resistor, I'll have to take this off anyway. Okay, let's pop this little board out here, and we'll see what's going on. So the 33 RPM is on the orange wire here, which goes through R3, and then through RV2, and then into the control. And we know that the control works because, of course, it's the same one used for 45. So it's either going to be this resistor, R3, or it's going to be RV2. That's bad. So let's measure the resistor first of all. That's all it can be, or a broken wire, but chances of a wire breaking are slim to none. So R3 is the resistor for the 33 speed, and R3 is measuring 148K. And it looks like 150K resistor, brown, green, yellow. So the resistor must be okay. So the problem must be the variable resistor here must be open. 3 megs. Yeah, it's probably open. Let's see what the other one measures. 19K. And this one's measuring 3 megs. So this pot must be bad. We'll just try just rotating it a bit more. Maybe it'll come back to life. Throw some more cleaner in there. It might be the wiper on the bottom. Okay, let's see if it'll attempt to turn now. If I turn it on. Still nothing. But it spins on 45. If I put my finger across here, drop the resistance, will it turn? Yes, it does, you see. So the pot is bad. If I short between the top contact and here, the motor should spin, which it does. So it's obviously on the carbon part that's bad. So the side that's open is this side. This side is open here between here and the carbon. The other side, though, is probably okay. Let's check it and see. If I measure between the wiper and the bad side, you can see it's open. If I measure between this side, it's good. So if I just short these two together, because as you can see one side is open anyway, if I just put them together, the control will operate, but it'll be going the opposite way. And I can do that just by putting a bridge right across here. Like that. If I wanted, I could cut the trace on this other side just so that in these slight chance that the pot started working again. But now you see the motor will spin in 33. So let's calibrate the speed. I'll do that before I put the board back in. We'll put the platter on and spin it up and set the speed so that both speeds are correct for 33 and 45 with the pitch control in the center. Okay, I'll set it for 45 first and make sure that my pitch control is in the center. So pitch control is in the center, and I will set the speed for the 45 RPM so that it's running the correct, which it actually is running the correct speed right now, or very close. And then I'll switch it to 33, and I'll set the speed for the 33 so that it's exactly going the right speed. You guys can't see what I'm doing, but what I'm doing is as you can see there you go, maybe you can see that. So now we're set for 33, and I switch it to 45, and it goes to 45, and I can just adjust the 45 speed just to make it exactly correct. So this top strobe is not moving, and I switch it down to 33, it drops down to 33. My pitch control works. There we go, and go up to 45, and just make sure that 45 is also going the exact speed. That's what these little trimmers are for. These little trimmers are to set up our speed. Now if I wanted to do a 78, I could just add another switch to change the value of resistor and add another pot, and that would give me a 78 speed. Adding a 78 RPM speed to this is actually a lot simpler than what most people would even think it would be. I can utilize this switch that I installed before as a kill switch for stopping and starting, because I don't use a turntable as a DJ anymore. I don't need to start it up and stop it. You know, for back cueing, I don't use a mixer anymore. I simply use my SLM1 if I'm cueing records for like recording. That's what I use my SLM1 for, is to record records onto my computer. So if I wanted to add 78 RPM on this unit here, I could utilize the switch that's already here. I know I've confused you guys completely now, but really all I need to do is add one wire to here. I don't need to change anything else. Right now how this operates is it cuts power off. When I switch the switch to the off position, like that, that disconnects power that's going currently to this switch, which is supplying power down either the brown or the orange wire that goes down to this board. So basically all I need to do is add a wire to here, add it over to my pot, and then the wiper, connect that to the output that goes back to the motor control. And that way I'll have a control that I can adjust the speed for 78. I've got my 33 and 45 controls here, and my pitch control will still work. So let's just add an extra wire. I'll hook a wire up to here, and then we'll mount this in the bottom and calibrate it using my phone for 78 RPM. And I don't know whether I'm going to be able to play anything with this bad cartridge with the kind of twisted needle, but we'll try it. It actually might still work. I don't know if there's a tip on here or not. Yeah, it feels like the tip's still there. The cantilever was a bit bent, so it might be okay. So let's just get a piece of wire. We'll hook it up to this side of the switch, and then we can mount everything. I'll bring the pot outside here so that I can adjust it, and then once I've got it calibrated, we can put it back together. And for those that want to see how this is being done on a schematic level, I will draw this in on the schematic to show you guys what I'm doing, so that you can understand exactly what we're going to accomplish here. So I'm just going to attach this yellow wire. We're going to put this onto this switch and then feed it down below the chassis. Then I can reinstall this faceplate. Alright, now I can put the faceplate back on. I guess I'll leave this until after I reattach the pitch control, because it'll make it easier to actually attach it. For now, I'll just turn the turntable over on its side so that I can attach the wires and hook it up. I'm choosing a 100K resistor just because the fact that the 45 RPM uses the 100K plus the actual control itself in series, so we're a little bit over 100K. What value is the pot on this one? Let's see here. It is 46K, so 150K if this was cranked all the way out. So around about 125 kilo ohms is what the value is for 45. For 33, it's 160 plus whatever the control is set to. So I figure going with a 100K resistor will get me probably in the ballpark. It's going to be less than 100K with this thing cranked all the way to 100. We might even be in the ballpark. I might have to go to a little bit higher value, but I don't think so. I think we'll probably be okay with a 100K resistor. I'm going to solder on the new wire that I put onto the to one of the pins here, and then the wiper is going to be connected to the wiper of the pitch control, so that I'll still have control, pitch control wise, even when it's in 78 mode, just like it is in 33 and 45. So there's that wire. I got to get another wire, and we're going to run that wire. We're going to run it right over here to the same common point junction that is going to the pitch control right here. This is the common point. So I just need to get another wire. We'll put it on there, put the pitch control back in place, and then we'll set it. It's another piece of wire. Try to be consistent with my coloring. Using wire that's much heavier than it needs to be, but it's just what I happen to have lying around. Hope I'm making sense to you guys. Hope my camera's recording. Didn't check. I might be talking to myself instead of talking to my audience. And this one can go right down here, attached to this board, right there. And that's it. That's the 78 mod. We'll just attach the control back in its place. That way I can set the front panel and put it back in place. Let's see if our mod works. With the switch in that up position, it'll be 33 and 45, and in the down position, it'll be the faster speed. So let's turn it on. 33.3, exactly. This should be 45. It's pretty darn close. Close enough, I can adjust that. Flip the switch, and now we can adjust our speed to get it to 78. Of course, when I touch the control, it changes it, so I gotta kind of let go of it after I make an adjustment, because my skin resistance is changing the setting slightly. 78.2, pretty darn close. I think that's close enough. What do you guys think? I think that's close enough. We can check our speeds out again. Let me go back to 45 and see if it's going to be... where's my 45 speed here? That switch probably needs some cleaning too. .33 1/3. We'll get this one adjusted for 45. Let's adjust the control in the bottom here. Can't see it very well, but it's close. Very, very close. I can do that with the pitch control. 78. 45. 33 1/3. Alright, just adjusting the pot on the bottom. 45.0. 33 1/3. It's close enough. 77.8. I think we're close enough. Let's actually try and play a record. Okay, I'm going to play... This was the one that everyone asked about, that my cousin was in this band when he was in high school in 1972. This one's called It's All About the Blues, is what the name of this track is. and then we'll try a 78 in a minute. Check the queuing arm, and it does pick the record up, and it also, this one's just an auto return, so that'll just shut it off. It's not an automatic, it's a semi-automatic. It'll just shut it off at the end of the record. So that's the 33 RPM. We know that that's working correctly. I'm going to try a 78 on it now, and I'll actually get some of my other 78s and we'll try them, but we're going to put a 78 on. We're going to flip the switch down to 78, and we're going to take a listen to this and see how this sounds. That sounds pretty good, actually. Let's try another one. I probably won't be able to get away with playing much of this, but I gotta play it. Harry James, one of my favorite artists from the 1940s. Let's just see what I've got here. We'll sample a few of these. This record is well worn. Oops. As I say, I can't play more than a few seconds of this because I know for sure this will pull a copyright strike or a copyright hit. This is one that everybody will know. One of my all-time favorites from Harry James. My dad had this in his collection on a reel-to-reel tape, actually. It didn't pick up at the end there. I wonder if it's just because the record doesn't go in far enough. Let's see here. It should automatically. Oh yes, it's just the I guess the inner groove is not quite far enough in on this one. Anyway, PS-T22 Sony direct drive. Excellent little turntable. This was a very highly rated turntable in its day. Inexpensive. Let's say it wasn't the super expensive one. It was the first good turntable I actually purchased, though. I haven't even checked the weight on this thing. You know, it's been sitting here all these years, and I haven't even checked it to see what I'm probably way too heavy. I am way too heavy. Ooh, we'll just balance this thing. Okay, so there's roughly 1.5, 2 grams. Okay, that's roughly 2 grams there. Anyway, this one. So it was the first turntable I bought, spending my own money when I was, I'm going to say I was probably 16 or maybe 17. Bought it in 1980. Bought it down A&B Sound to make mixed tapes for my car. And this thing got a lot of play, but I say I haven't used it in years. I know you guys want to know what I did to modify this thing, so let's go over the schematic together so I can show you guys what the mods are to make this thing play 78. It's actually one of the simplest mods that you'll ever do to any piece of equipment, but here's the circuit that we're working on. Okay, it's a feedback loop. So whatever color that wire was, red, I think it was a red wire. Red wire's coming up, it's going to the speed selector board, right? And it's selecting 33 or 45, where it goes back through the pitch control board, and it's going through a resistor and a variable resistor, as you can see here. 33 goes through a 150K resistor and then through RV2. 45 goes through a 47K resistor and through RV2. This is what? RV1. And then both of those go into the pitch control. So all I did was I just put another switch here. So this is where I put the switch, right? I broke the circuit here. I broke this and I put a switch here to turn it on and off for cueing. The other side of that switch, I just brought it out through another resistor, a variable resistor, and then the output of this variable resistor, I tied it down right there. So in one position, the power comes out, it goes in, it goes down in through the 3345 switch and through the existing resistor network, and when we flip it the other way to 78, okay, now it's going to shut this circuit off. It's going to go through my new 100K resistor, and then it's going to go back into the pitch control. And that's the mod. That's how simple it is, a switch. I already had the switch on the unit before, so I didn't have to drill any holes because I already had a switch. I had a switch here to shut it off because, as I was explaining before, I used to cue this up and play records using a mixer. So I would play the record, shut it off, back cue it one turn, and then when the other song was fading, I could just go hit the mixer and it would mix in, and my SLM1 had a start-stop button on it already. So I could start and stop that one. And that's what I used to do, and then flip it off. Now this switch, 78 down, up is 33, 45. All goes through the pitch control. Everything's been calibrated so that where the pitch control is centered. I've got 33, 45 verified, and 77.7. That's as close as I could get it. I mean, if you want to play around with the pitch control, you can get it exact, but really 78 records. We're never at 78 anyway. Most of them were between 76 and 80. It was just luck of the draw when they made the recording what speed the lathe was turning at. Most record players of the day that ran 78 ran anywhere between about 75 and 80 RPM. So they just averaged it out. Okay, let's make it 78, because really, depending on basically the time of day when you're playing your records, if the voltage was a little bit higher, the speed would be a little bit faster. If you're playing your records at dinner time, they slow down a bit when everybody's cooking dinner because the voltage is dropping a bit. Anyway, that's that. Let's take a look at the cartridge here that is not in the greatest shape. The cantilever was nicely bent on this, and I've kind of tried to straighten it up just by bending it back. But as you can see, I think I got it relatively straight. It's not in the greatest shape, but it's an original Sony, and I don't think I would ever find a Sony VL5 cartridge today, or an ND5G. But if I could find another ND5G, I would certainly replace it. I'm going to hang on to this turntable. This is going to be part of my collection. That's why I went ahead and did the modification to make it play 45 or make it play 78s, because I do have a few 78 records that I would like to play, even though I do have an old 78 record player. I've got a couple of old 78 record players that actually have the right stylus to play 78s, but now I have another option if I want to record them. It's a stereo cartridge, but I mean, mono it out, hit the mono button, they sound good, they sound fine. Turn the treble down a bit because there's a lot of hiss, a lot of scratch and stuff. The smaller stylus will pick up a lot of noise and so forth from worn records, but 78 records, most of them were pretty noisy to begin with. The correct stylus will certainly obviously make them play a bit better, but it is what it is. Before I end this one, I figured I would go over how this operates, because some of you may not be familiar with how this type of turntable operates. This one has a feedback loop, which, I mean, all direct drive turntables do, but not all of them do it the same way. A lot of them just pick up the speed off of the motor itself. And this one here uses an external speed detect head over here, which has got that inner coating on the inner side of the platter, which has got a magnetic signal recorded on it. It's a sine wave, right? It's just a sine wave. So if you were to expose this to a strong magnetic field, you could damage it, and then of course the speed would be inconsistent. So it's important to keep these turntables away from things like tape erasers or big magnets, because that is going to cause problems. But basically there's a signal on here, and that signal is, what frequency does it say? Does it say what my frequency is? I could put a frequency counter on there, but anyway, it goes into an amplifier, which is then clipped and turned into a square wave signal, which is then sent into the Schmitt circuit and a trigger pulse generator into the servo amplifier, which through a comparator creates a sawtooth voltage, which is then sent into a DC amplifier, sample and hold basically. And that is used to control the motor drive circuit that drives the two coils. There's 4 coils, but it's only basically a 2-phase system. So there are 4 coils in the motor section. They are in series with each other, L1 and L2 on opposite sides, and the output transistors can draw it to positive 15 or negative 15 volts. So we're creating an AC waveform, and we're creating 2 waves that are out of phase with each other to create the rotating magnetic field, similar to what a 4-pole motor would operate on. It's not a 3-phase. Some turntables like my SL-M1, for example, uses a 3-phase closed loop servo circuit. This is not. This is just a 2-phase system, and it's creating the 2 phases here in the amplifier. This creates a rotating magnetic field. So there's 2 Hall effect sensors, H1 and H2, that are actually mounted underneath the rotor itself. as the unit applies power, it'll apply a magnetic field to one of the coils to start the turntable turning, which is then detected by these Hall effect sensors, which tells the system where the rotor is, what position the rotor is in. That is used to create the second drive signal for the second coil to create the rotating magnetic field. And that's H1 and H2. And two of those controls, the gain pots, were here. And which one? I'm just going to take a look and see which pot was the one that was causing it not to turn. It would have been one of these gain pots that was dirty that I cleaned up. And I know which one it was. Let me just take a look and see. I'll tell you guys which one was causing it not to rotate. So there was the 4 pots on the bottom on the bottom of the circuit board, which I initially cleaned. The one that was actually causing me trouble was this one here, RV6, which is the balance control on the drive IC for the output. So with this one here not working correctly, this is what provides the control voltage, as you can see here. One of them provides the control voltage from through this 330 ohm resistor off of the positive 13 supply. So initially this resistor was open, right? So we had nothing here, no voltage here. So the circuit was dead. When I gave it a spin, it kind of went, but it wouldn't go the right speed. There was no control, there was no servo control, because this entire circuit over here was dead. There was no power getting to it. Once I replaced, so the first thing I did was try cleaning the controls, which of course did nothing because there was no power getting to it. We replaced this resistor that was open, and that restored power to here, but RV6 itself, the pot itself, wasn't making a good connection, and this IC wasn't operational, so that it still wouldn't spin. There was no rotating magnetic field, and I just rocked the controls back and forth a few times to let the cleaner work its magic. It was probably on the back side of the control, like these controls that are in here are similar to, I think I've got one here that's similar to them. They're like these, right? They're control like this. So it was more than likely on the back side of the control here where the wiper is connected. The wiper is this piece here, right? It's connected through a physical connection there that can turn, right? So when you turn the control, I just polished it, the connection in here between the wiper and that contact. Anyway, that's all it took was to do that, and then the unit started to rotate. That got that part fixed. Our 33 wasn't working because this control here for the 33 speed was also bad. So what I ended up doing was, this is the one here, 33. If you look at the control, I know the print is not great, but if we look down at the control, you'll see that one side is open. Right, so there was a break right here. So there was no connection, so all I did was I just jumpered around and hooked it up to the other side over here. So that the control is backwards, right, because this side is broken, rather than change the control because I didn't feel like it, I didn't have a control. And then of course for the 78 mod we just rewired that switch, which had been used to disconnect power, to shut it off and make it stop. We just rewired that switch, added a 100K variable resistor, so that when it switched to 78, it bypasses the 33 and 45 RPM speed control, puts in the new variable resistor, and applies it over here to the pitch control, so we get 78 RPM. That was pretty simple. Anyway, that's the deep dive for you guys that want to see the deep dive on this. I know that if I didn't, somebody would be asking. But anyway, it's it's a feedback circuit. It's actually measuring the speed of the platter itself, as opposed to just the speed of the motor, which most direct drive turntables, they will detect the speed of the motor itself, either using the Hall effect devices, or some of them will actually have an FG similar to this that's mounted on the rotor itself. Sony chose to use an external head because it's using a much larger surface area, so it's a little more accurate, they say, because it's a larger surface area and it's actually measuring the speed of the actual platter itself. Anyway, we'll close this one off. I've got another one from Harry James that we'll close this one off with The Flight of the Bumblebee. Thanks for watching. We'll catch you in the next one.